For this Centrifugal Pump Minute, we're going to be discussing how to calculate NPSH available for a pump that is installed and operating. My name is James Farley, and I'm the Griswold Product Manager. Why does NPSH available matter? Cavitation. If a pump is cavitating, you will see excessive vibration and also rapid degradation of the hydraulic components, such as you see in this impeller. If there is a concern that a pump is cavitating, the first thing you need to check is the system NPSH available. So here's the data points we're going to collect: suction head, vapor pressure, velocity head, gauge height, and friction loss. By taking these 5 variables and using this formula, we can now calculate NPSHA. Now let's go to the test lab to collect our data. Now that you understand how to calculate NPSH available, we're going to show you how to take a few readings off of the pump and how it's performing in the field and calculate it and determine if this pump is cavitating or not. First of all, we need a temperature reading. If you have fluid temperature in the system, great. If you don't, you can use a simple infrared temperature gun to take a temperature at the suction of the pump. In this case, the temperature is 67 degrees Fahrenheit. We then also need a pressure reading at the suction of the pump. We have an absolute pressure gauge that's measuring at 16.3 psi. Using the temperature and pressure, we're now going to calculate NPSH available. So here are our data points. We converted our suction pressure into suction head in feet. We took our temperature reading and converted that into vapor pressure in feet. We also have to take into account velocity head. And in this case, we're using velocity head in a 3-inch pipe and 400 gallons per minute flow. We also need to take suction gauge height, which was 1 foot above the center line of the pump. And finally, we need to take into account friction loss. And again, with a 3-inch pipe at 400 gallons per minute, friction loss for us would be about 0.35 feet. Using these values, we can now calculate NPSH available. And in this example, our NPSH available comes out to be 42.7 feet. The next step is you'd have to compare the calculated NPSH available to the published NPSH required for the pump to determine if the pump may be cavitating. As discussed earlier, we know that cavitation can cause excessive vibration in a pump. And so with the pump not cavitating, we took a baseline vibration reading, and you can see those on our screen here. Right now, all of our vibration readings are well below the acceptable limits on the pump, and this is how the pump will want to operate for a long, reliable life. As mentioned at the beginning of the video, cavitation also causes excessive vibration. And excessive vibration can cause premature seal failure, bearing failure, and other types of failure within the pump. We have taken vibration readings, vertical, horizontal, and axial, while the pump is cavitating. And you can see that all readings are well above the allowable vibration limits. If this pump is operated in this condition for a long period of time, it will fail prematurely. So now you know how to properly determine your NPSH available and ensure that your pump is not cavitating during operation. Thanks for joining today's Centrifugal Pump Minute.